An uninsulated cylindrical wire of radius 1 millimeter produces electric heating at the rate of 5 watt per meter. The temperature of the surface of the wire is 75 degrees Celsius when placed in air at 25 degrees Celsius. When the wire is coated with PVC of thickness 1 mm, the temperature of the surface of the wire reduces to 55 degrees Celsius. Assume that the heat generation rate from the wire and the convective heat transfer coefficient are same for both uninsulated wire and the coated wire. Now the thermal conductivity of PVC in watt per meter Kelvin rounded off to 2 decimal places is what? So we need to find the thermal conductivity of PVC. We are given an uninsulated wire of radius 1 millimeter. So the radius given here is 1 millimeter. Let's write R1 for this radius. Okay, so R1 is given 1 millimeter. Now the heat per unit length in this wire is given 5 watt per meter. So we can write here, let's write here Q by L is equal to 5 watt per meter. The surface temperature, so the surface temperature, let's write TS1 is given as 75 degrees Celsius, and the free stream temperature, let's write this free stream temperature somewhere here. Free stream temperature T infinity is given to us as 25 degrees Celsius. Now the convection heat flow through the surface is given by Q is equal to H, that is the convective coefficient of heat transfer, into A, the area, surface area, into the surface temperature minus the free stream temperature. So this is the expression for convective heat transfer. Convective heat transfer through the surface. Okay, so this is the expression here. Now let's proceed with this solution. So H is unknown here. Area we know is 2 pi r, this R1, let's write here R1 into L, because the length of this wire given to us is L. Okay, R1 into L. Now this L is also unknown here because it's not given in the problem. The temperature, surface temperature is 75 degrees Celsius minus this T infinity. T infinity is 25 degrees Celsius. And the heat per unit length is also given to us, that is 5 watt per meter. So we can write this expression. Okay, this is, now from this expression we can calculate H value. So we can write H is equal to Q by L, this whole divided by, let's write here, whole divided by 2 pi R1. 2 pi R1 is 1 mm and 1 mm is 0.001 meter, multiplied by this temperature difference. Here we are taking the temperature difference, so there is no need to calculate it in Kelvin or the SI unit, because the temperature difference in Kelvin and temperature difference in degree Celsius is the same. So here it will be 50, right? And we can find from here, because Q by L is given to us, that is 5. So let's write here itself, Q by L is given to us as 5. Okay, so H will be 15.92 watt per meter square. So we have got the value of convective heat transfer coefficient, that is 15.92 watt per meter square. Now in the second case, it is said that the PVC coating of 1 mm is applied. So that means this thickness is 1 mm. So let's say the total radius is R2. So R2 will be equal to thickness T. So this is the thickness T, thickness of PVC, plus R1. So this will be 2 mm. And that is equal to 0.002 meter. Now after applying the PVC, the surface temperature reduces to 55 degrees Celsius. So let's say TS2 is equal to 55 degrees Celsius. Also let the thermal conductivity of this PVC coating be K. Okay. Now we see here there are two materials. one is this wire and this PVC coating over it. So we can say it's a composite cylinder with uniform heat generation. Okay, so there will be conduction of heat in radial direction as well, right? So for radial direction, so the heat flow per unit length can be written as, so let's write therefore Q by L for this composite cylinder in radial direction, we can write Ts2 minus T infinity. T infinity is the free stream temperature. This whole divided by ln R2 by R1. R1 is the radius of the wire and R2 is the radius of wire after coating, divided by 2 pi K. K is the thermal conductivity of PVC material, plus 1 by H into 2 pi R2. Okay, so now using this equation, let's substitute the value as it is mentioned in the question that the heat generation rate, we have to assume it to be the same for both the cases. So let's write the value as 5 because it's given 5. Now the surface temperature T2 is given 55 degrees Celsius minus free stream temperature is 25. Okay, so whole divided by ln R2 is 2 and R1 is 1 divided by 2 pi K. K value is unknown, plus 1 by H. H, we have found out the value of H, that is 15.92. So let's write here 15.92 into 2 pi R2. R2 is 0.002 meter. Here we are not converting in meter, that R2 as well as R1, because this is a ratio and it will get cancelled out anyway. So the ratio will remain same whether it is in meter or whether it is in millimeters. Now from here, if we calculate the value of K, we will get K is equal to 0.11 watt per meter Kelvin. Now let's go back to the question and fill in the blank. The thermal conductivity of PVC is 0.11 watt per meter Kelvin. To get more information on this type of problems, you can refer to the NPTEL course of lecture number 7, problems on 1D steady state heat conduction in plane wall on conduction and convection heat transfer by Professor S.K. Soom of the Department of Mechanical Engineering at IIT Kharagpur.